Hi, this is a prototype version of my robots. What I want my robot to do is shoot a ball into a cup. In order to do that, I need to calculate my cannon velocity, the yaw angle, which is the horizontal angle, the pitch angle, which is the vertical angle, and then I can shoot. In this video, I'm going to be showing you how to calculate the cannon velocity. Let's say that this is my robot. When it shoots, it lands, and I'm going to measure the distance between the base of the cannon and where it lands. That will be my X.
Can't see.
And now I'm going to calculate my time. Y minus Y naught.
Why?
Y is the distance between the cannon barrel and the table. And Y naught is 0 in this case. So Y is equal to V naught T V naught T plus 1/2 AT squared. So now that I know my Y, and since I know my Y, and I know that I'm shooting this cat, I know that dropping something takes the same amount of time to land as shooting it. So I'm going to assume that I'm dropping it, so D naught equals 0. And acceleration is gravity. So I'm going to multiply both sides by 2 and divide by gravity. 2y over g is equal to time square. I'm going to take square root of both sides, so time is equal to 2 square root of 2y over g.
Now what angle do we shoot the cannon at?
We're going to shoot the cannon at a horizontally 0-degree angle, because if we shoot it at anything other than that, like a negative or anything larger than or less than 0, it's going to actually affect our calculations, and we can't really assume we're dropping it because it's going to shoot because there's an upward velocity or downward velocity. Now that I know my X, I know my time. So now I'm going to calculate my initial velocity. So our X, which is X minus X naught in this case, is equal to V naught T that's 1/2 AT squared. Acceleration is equal to 0.
Why?
Because we're now calculating the horizontal velocity and vertical, and you can't have an acceleration going downwards. You can't have gravity while you're calculating horizontally. So now I'm going to solve for my velocity initial. So I'm going to divide time from both sides. So V naught equals X divided by time. Which I'm going to use substitute. And I'm going to simplify this, which is also equal to X over 1 divided by square root of 2y divided by g, which is equal to...
How did you get the square root of 2 over yg? Please show your work. It's not clear.
2y over g.
Show your work, please.
Which is equal to x divided by...
Can't see.
to time, which time is 2y over square root of 2y over g. So this is equal to x divided by 1 all over by...
Is that multiplication sign?
Sorry. All over by 2y divided by g, square root of that, which is equal to x divided by 1.
Multiplication sign.
Divided by 1 times square root of g divided by 2y, which I'm gonna square my x, and then I'm gonna square my x so I can move it into the square root for multiplication. So this is equal to square root of g x square divided by 2y, and this is equal to our v naught. Now that I have the calculation for my initial velocity, I'm going to show you how using numbers. So I'm going to shoot the ball now. The ball, I believe, landed right about over here. So I'm going to make a mark so I can see where the ball landed. So I can measure it.
Where did you get that paper from? What is that?
This paper is called impact of carbon paper, which come in a couple different forms. It is made so that when there is impact on the paper, it makes a mark on any paper beneath it. As you can see, this type of impact paper comes with the paper underneath, and this type actually has more area. So I'm going to measure this, so my x is equal to...
Where do you start measuring from? Can you show
from the base of the cannon over here, which is about right over here, to the mark of where it's shot, which is about 41 inches. So I can say x is equal to 41 inches. Now I'm going to measure my y, so y is looking at this, y is equal to about is equal to 11.125. As you can see here, it looks like it's exactly 11 inches, but since there's on the bottom over here, there's about there's space over here is about 0.125 inches. So it is 11.125 inches. So that is my y.
Can't see.
But since I want everything to be in meters, I'm going to convert this from inches to meters. So I'm going to multiply this by times 0.0254 divided by 1 inch.
254 what?
254 meters divided by 1 inch. The inches cancel out. So I'm gonna check on my calculator. Zero point 0.0254 times 41 is equal to 1.0414. So that is my X in meters.
Can you make the decimal place look better? It doesn't look, it's not clear. Thank you.
And now I'm going to do the same thing with my Y. I'm going to multiply this by 0.02554 meters all over by 1 inch. Divided by 1 inch. So the inches cancel out like last time. So 11.125 times 0.0254 is equal to 0.28257. meters. Now that I know my calculations for my X and my Y, I'm going to calculate my initial velocity. So 9.
Can you write down on the screen before you put in a calculator?
Yeah. 9.81 meters over second square times 0. No, wait, not 0. 0.0414 meters square divided by 2 times 0.282575 and take square root of that, and that's your velocity.
Can you write velocity equals that?
So now I'm going to put this in a calculator so I can actually figure out the actual number for meters per second. So 9.81.
I think you're missing your units.
It's supposed to be meters over here, and this is my velocity. So 9.8, since I'm plugging it into a calculator, I can't specify the exact units, but I'm going to calculate the units over here. So 9.81 times 1.0414 square, and then divided by 2 times 0.28257 equals, so that is equal to and now I'm going to take square root. So velocity initial is equal to 4. So my initial velocity is equal to 4.3806.0579. So now I'm going to check the units. Meter square over second square divided by meters. So that's meters of, so that would be meters square over second square, which would equal to be meters over second, which meters per second is actually meaning another word for basically is a speed, and velocity is a word with higher terminology than speed. This is how you calculate the velocity of my robot. Hope you like my presentation.